Hello everyone and welcome. In this video, I'm going to talk about the stack data structure. So this is a data structure that follows an idea called FILO, and this stands for first in, last out. Essentially, what this means is that the first element that you put in the stack is going to be the last that you're going to take out or process. So I'm going to give you an example of a stack of plates. You're always going to put the plates at the top of the stack, right? And if you want to remove a plate, you're going to grab the plate at the top and remove it. So essentially, the first plate that you put in the stack is going to be the last plate that you're going to take out or use or clean or whatever you want to do with it, right? So that's the idea of a stack. Now you could implement this using a linked list. However, I'm going to teach you how to implement it using an array. So this is really easy. Essentially, the array is going to have a bunch of indexes, and you're going to have a variable called top, which is going to store the top index of the stack, right? So if you want to add an element here, you just grab the top and you move it up. You want to add an element here, you grab the top, you move it up, right? So if all of these are filled, then the top is going to be up here, right? And if you want to remove an element, you grab the top and you move it down, right? And you don't really need to do anything to the element that you've just removed because the stack is only going to be below your top, right? Anything that's over your top is not going to be inside of the stack anymore, right? So for that reason, you can only really add or remove elements from where the top is, right? So that's the idea of the stack. Now let's actually implement this in code. I'm going to represent my stack with a struct called stack, like so. In here, I'm going to have a couple of attributes. First, a top, which is going to store the top of the stack, and then the stack itself, which is just going to be an array of length max. I've defined it to be 100 up here. Then we're going to have our constructor stack like that. And in here, I'm just going to say that the top in the beginning is going to be -1, right? So in the beginning, the stack is going to be empty. Now I'm going to have a method here, which is going to return a Boolean. I'm going to call this isEmpty. And in here, I'm going to check if the stack is empty or not. In order to do that, I'm just going to return top is smaller than 0. So why does this work? Well, that's because we're going to increment the top when we add elements, and we're going to decrement the top when we remove elements, right? So the stack is going to be empty if the top is smaller than 0. All right, then we're going to have here a method called push, and this is actually adding here elements to the stack. First, we're going to have here the value that we want to push. And inside of here, I need to check if I have positions left. How do I do that? Well, I'm going to say if the top is greater than or equal to my max -1, that means that the stack is empty, right? So it doesn't really make sense to put more elements inside of the stack. I'm going to cout here, \n, and then stack overflow like this, and then a \n, and I'm just going to return because I don't really want to do anything. Now, otherwise, I'm going to say that the stack at ++ top is going to be the value. So essentially, I'm going to increment the top and I'm going to put the value in that position. And that is the push method. Then we're going to have pop, which is removing an element from the top of the stack. And this is going to return to us the element that we are removing, right? I'm going to say if this dot is empty, like so. So essentially, if the stack is empty, it doesn't make sense to remove an element from the stack, right? So I'm going to cout stack is empty, ! Like so. And this is going to tell us that the stack is empty. And I need another \n here. And then I'm just going to return 0 as a code to tell us that something went wrong, right? Then I'm going to say that int value is going to be the stack at the top, so essentially the element we're going to remove, and I'm also going to decrement top, and then I'm just going to return the value. So this is the pop method. Then we're going to have a peek method, and this is just going to return to us the element at the top of the stack. Now I'm actually going to grab this because it's the same verification, and I'm going to paste it right there, right? If the stack is empty, it doesn't really make sense. And otherwise, I'm going to say that the int value is going to be the stack at the top and I'm going to return the value like so. So this is how you see the top of the stack essentially. Then the last method I'm going to have is going to be a display stack like so, just so that we can see the elements in our stack. I'm going to say for int I equals 0, I is smaller than top, and I forgot I++. Let's say see out the stack here at the position I and a \n, and this allows us to see the elements of our stack. All right, so that is the implementation of the stack. Let's actually see if this works. I'm going to create a stack S here, like so. And let's put a couple of elements here in the stack. So stack.push. And what is this telling me? Okay, so this is not these parentheses. I need to call the constructor. Okay, now I'm going to push a couple of elements. And then I'm going to display my stack like so. And let's run this to see if it works. Let me pull this up. And this is our stack. We have an element missing. Okay, because this needs to be smaller than or equal because the top is also going to have an element. Let me run this again. All right, and now we can see our stack. Now let's use the pop method. This is going to remove an element from the top of the stack. So it's going to be 21 in this case. Okay, so 21 is removed. And then I'm going to see out stack.peak and a \n. And hopefully this is going to give us 13. All right, so it gave us 13, the element at the top of the stack, and then the elements in the stack. All right, so that is the implementation of the stack. I hope this was helpful and easy to understand. If it was, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next video.